Hello students, good morning. Today we will discuss principles and methods of fruit and vegetable preservation under the course title Post-Harvest Management and Value Addition of Fruits and Vegetables offered to 6th semester 2017-18 batch. In the post-Green Revolution era, although food grains have been taken care of, fruit and vegetable, for want of simple technologies of processing, preservation and transport to various places of need, have suffered deplorably, and it is estimated to be more than 25% spoilage of fruit and vegetable in the lack of proper post-harvest facilities, and only about 1% of the total fruit and vegetable produced are processed. This is the scenario. All forms of preserved fruit are in the reach of only the urban population. The rural masses, who produce more than 90% of the fruit and vegetable, are usually deprived of their uses. Now, principles of fruit and vegetable preservation. What are the principles? Actually, the principle is based on the causes of spoilage, spoilage causing factors. Three factors are there which causes spoilage and decay of fruit and vegetables, which are microorganism, then enzymatic oxidation, and damage by insect, animal and mechanical causes. So, if we minimize, retard or check these spoilage causing factors, then we can preserve for long span. So, this is the principle of fruit and vegetable preservation, that how to make the shelf life of fruit and vegetable longer. So first one is prevention or delay of microbial decomposition. It is conducted by keeping out microorganisms like asepsis, by removal of microorganisms like filtration, by hindering the growth and activity of microorganisms, that is low temperature, drying, anaerobic conditions, chemical or antibiotics, and by killing the microorganism, that is heat or radiation. Second one is prevention or delay of self-decomposition of the food by distraction or inactivation of enzymes, which are mainly built by protein. Example, by blanching. Blanching is high temperature treatment, about 82 degrees Celsius, to the horticultural commodities, as you are aware. Now, by prevention of or delay of chemical reactions, example, prevention of oxidation by means of antioxidants. And third one is prevention of damage by insect, animals and mechanical causes. These are the three main principles of fruit and vegetable preservation. Techniques or tools by which the food preservation can be taken. First one is, altogether 14 methods are there by which shelf life of fruits and vegetables can be enhanced. These are, namely, first one is asepsis. Asepsis means absence of infection. Means it is the prevention of entry of the microorganism and maintaining general cleanliness while picking, grading, packing and transporting of fruit and vegetable. Increases the shelf life and shelf life of the fresh product as well as the processed one. Washing or wiping of the fruits and vegetables before processing should be strictly followed, as dust particle adhering to the raw material containing microorganism, and by doing so number of organisms can be reduced considerably. Second one is prevention of spoilage causing factors by high temperature. Coagulation of protein and inactivation of their metabolic enzymes by the application of heat leads to the destruction of microorganisms present in food. Further heating can also inactivate the enzymes present in the food. Heating food to sufficient high temperature therefore help to preserve it. This is the table which shows thermal death time, means the time taken for the complete destruction of the microorganism. Here we can see different bacteria are there, and like Salmonella typhosa 4.3 at 60 degrees Celsius, Staphylococcus 18.8 at 60, E. coli 20 to 30 at 57.3, Streptococcus 15 minutes for 70 degrees Celsius, Lactobacillus bulgaricus 30 minutes and 71. Might be aware of the very common terms like pasteurization and sterilization. At first, we will discuss pasteurization. Pasteurization can be done in two ways: by heating it at low temperature for long period, or by heating at high temperature for short time. These two methods can be applied. Now, different types of pasteurization. Bottle or holding pasteurization. Bottle or holding pasteurization, it is the normal method of pasteurization, in which extracted juice is strained or clarified as the case may be and filled in bottles, leaving sufficient head space about 2.5 centimeter for the expansion of the juice during eating. The bottles are then sealed airtight and pasteurized. Then overflow method. In overflow method, the temperature is taken 2.5 degree Celsius higher than the pasteurization temperature and then filled in the hot sterilized bottles up to the brim. Third one is flash pasteurization. In this method, the temperature is kept about 5.5 degrees Celsius higher than the normal pasteurization temperature and kept at this temperature for a minute. And this method is very advantageous, as loss of flavor is minimum, vitamins are not destroyed, and it is economical and time saving. Now for reference, the difference between pasteurization and sterilization. Pasteurization is it is done normally temperature below 100 degrees Celsius, while sterilization at or above 100 degrees Celsius. In case of pasteurization, partial destruction of microorganisms is observed, while in sterilization, complete destruction of microbes taken place. And pasteurization is used in case of fruits, while sterilization is normally used for vegetables. One rapid sterilization process is also there, in which commodity is subjected to 149 degrees Celsius for 1 to 2 seconds, and it is referred to as ultra high temperature UHT sterilization. Now this is the data which shows which bacteria takes how much time to kill at 100 degrees Celsius. Here we can see that flat sour bacteria is taking maximum time 1000 minutes to kill at 100 degrees Celsius, and Bacillus anthracis 1.7, Bacillus subtilis 15 to 30, Clostridium botulinum 100 to 3. Preservation by low temperature. Like high temperature, low temperature is also very effective in retarding spoilage of fruit and vegetable. Three sub part of low temperature, like cellar storage. Cellar storage is nothing but it is underground storage of horticultural commodities, like for mainly meant for root and tuber crops, in which storage is taken underground, because that place is relatively cooler than the above surface, about 15 degrees Celsius. Now refrigeration or chilling. Chilling temperature are obtained and maintained by means of ice or mechanical refrigeration about 0 to 5 degrees Celsius. Freezing -18 to -40 degrees Celsius. Freezing is the most harmless method of food preservation. Microbial growth is inhibited and the rate of chemical reaction is slowed down at low temperature. And different types of methods are there for bearing this freezing, like placing them in contact with coil through which the refrigerant flows, blast freezing, dipping in liquid nitrogen, etc. Preservation by chemical. Fourth one is preservation by chemical. Microbial spoilage of food product is also controlled by using chemical preservative which do not include salt, sugar, acetic acid, oil, alcohol, etc. but only microbial antagonist. The inhibitory action of preservative is due to the interference with the mechanism of cell division, permeability of the cell membrane and activity of enzymes. According to British Food and Drug Act of 1928, a preservative is any substance which is capable of inhibiting, retarding or arresting the process of fermentation, acidification or other decomposition of food, but does not include common salt, that is sodium chloride, saltpeter, sodium or potassium nitrate, sugar, acetic acid or vinegar, alcohol or potable spirits, spices, essential oil or any other substances added to the food by the process of curing known as smoking. The two important chemical preservatives permitted in many countries are sulfur dioxide, including sulfides, and benzoic acid, include benzoates. These two chemicals are allowed in India also according to the FPO order 1955. Sulfur dioxide. Sulfur dioxide is widely used throughout the world in the preservation of juice, pulp, nectar, squash, crush, cordial and other products. It has good preservation action against bacteria and molds and inhibits enzyme, etc. And its formula, chemical formula is K2O into 2SO2, that is K2S2O5. Potassium metabisulfite. Sulfur dioxide is released by this chemical, potassium metabisulfite, KMS. It is off-white color and it is used for the release of sulfur dioxide in preservation of food. but some limitation of SO2 are there, that it cannot be used in case of some naturally colored juices like falsa, jamun, pomegranate, strawberry, colored grapes, plum, because it is having bleaching action. Second one is that it cannot be used for juices which are to be packed in tin containers, because it does chemical reaction with the tin plate and corrosion takes place. So these are the limitation of sulfur dioxide. Here is the chemical reaction. We can see that KMS with citric acid result into potassium citrate and SO2 and water. And SO2 and water gives sulfurous acid, and this sulfurous acid takes care of the spoilage of food. This is the chemical formula. Second chemical is benzoic acid. Benzoic acid, it is only partially soluble in water, hence its salt, sodium benzoate, that is benzene ring and COONA, is used. 1 part of sodium benzoate is soluble in 1.8 part of water, and this sodium benzoate is 170 times as soluble as benzoic acid. That's why sodium benzoate is taken as the chemical, and its efficacy is increased in the presence of CO2 and acid. Bacillus subtilis cannot survive in benzoic acid solution in presence of carbon dioxide, and it is also very helpful in preservation of colored commodities, and it does not have any bleaching action. Preservation by drying. Preservation by drying means actually main media for the spoilage is, as we all know, that it is water. If the content of water is lessened, then the the keeping quality of horticultural commodities can be enhanced, as all we know. So drying process is there, by which the water is expelled out, and the two terms are there, drying and dehydration. For natural drying is there, and when it is conducted by means of some artificial water expelling activity, it is known as dehydration. One term is also there for this drying: reconstitution and rehydration ratio. When dried products are again dipped into water, again administered water, and it is rehydrated, then final rehydration weight and the weight of the dried commodity is known as reconstitution and rehydration ratio. Preservation by filtration. Preservation by filtration, actually this is very modern technique, and mainly it is come in use in USA and Germany for preserving apple and grape juices. In India it is very nascent stage. Actually some filters are there, some specific very precise filters are there which filter microbe out of the juice and the commodities. So this is one of the method, preservation by filtration. Now, preservation by carbonation. As we all take these soft drinks like Pepsi, Coca-Cola and others, this is nothing but dissolved sweetened carbon dioxide and produced by the process of carbonation, and complete inhibition of microbial activity takes place about 14.6 gram per liter concentration of carbon dioxide, and generally 1 to 8 gram per liter concentration is used for the preparation of carbonated beverage. Sugar syrup. Solution of sugar is known as syrup, while solution of salt is referred to as brine solution. Syrup containing 66% or more of sugar don't ferment. One term is there, osmotic dehydration. So because of the high concentration of sugar, or also in case of salt, the due to osmosis, the plasmolysis of the microbe takes place and thus it is destroyed. And this is the principle of application of sugar and salt. So sugar above 66, about 66%, 65 to 66% is sufficient to kill the microbes and to retard other spoilage causing factors. Now, preservation by fermentation. Fermentation, as we know, that decomposition of carbohydrate by microorganism or enzyme is called fermentation. It can be acetic fermentation by Mycobacterium aceti, in which vinegar is produced, maybe lactic fermentation in which curd or yogurt or similar substances formed by lactobacillus and other strains of bacteria, and alcoholic fermentation in which ethyl alcohol is produced by the action of yeast Saccharomyces to the carbohydrate source. All the student knows very well this thing. Just I am repeating. So by the application of fermentation, this food preservation can be also taken. About 2% of acetic acid prevents spoilage in many products. Preservation by salt, like sugar, salt also act barrier for microbe and oxidative processes, and about 15 to 25% sugar is generally recommended for preservation. It exerts its preservative action by causing high osmotic pressure resulting in the plasmolysis of microbial cell, as we have discussed, dehydrating food as well as microorganism by drawing out the tying up moisture by ion hydration, ionizing to yield the chlorine ion which is harmful to microorganism, and reducing the solubility of oxygen in water. So these are the action which salt and some are carried by sugar also. Preservation by acids. Some acids are also very helpful for preserving long this fruits and vegetables, like acetic acid, which is main constituent of vinegar, citric acid, lime juice, and lactic acid are commonly used for preservation. About 2% acetic acid prevents spoilage of many products. Preservation by oils and spices, that is pickling. Oil, a layer of oil on the surface of any food produces anaerobic condition which prevent the growth of mold and yeast. Thus, pickle in which enough oil is added to form a layer at the top can be preserved for long periods. This is the main principle, that oil creates anaerobic condition, and spices like turmeric, pepper, asafoetida have little bacteriostatic effect. Bacteriostatic effect, all are acquainted. Bactericidal means killing of bacteria, and bacteriostatic means restricting their growth. Bacteriostatic effect and their ability to prevent growth of other microorganisms is carried out. This is the primary function, and their primary function is to impart their characteristic flavor to the food, and side by side they also give bacteriostatic effect to the preservation by antibiotics. Preservation by antibiotics, as we used to take different type of antibiotics like ampicillin, erythromycin. Similar type of antibiotics are also used for food preservation. In case of food preservation, only three antibiotics are used till date. These are nicene, subtilene, and pimaricin. Nicene is an antibiotic produced by Streptococcus lactis, commonly found in milk, curd, cheese, and other fermented milk product. It is non-toxic and also no adverse effect on the sensory quality of food. It is widely used in the food industry, especially for preservation of acid food, in which it is more stable. Nicene suppresses the growth of spoilage organism, mainly the gas-producing spore-forming bacteria and toxin-producing Clostridium botulinum. Subtilene, it is extracted from Bacillus subtilis and used for the preservation of asparagus, corn, and peas. It is most effective against gram-positive bacteria and spore-forming organism. And last one is pimaricin, which is an antifungal antibiotic and can be used for treating juices. Last one is preservation by irradiation. Irradiation is also, though many controversies are there for irradiation, use of irradiation in food, but this is one of the method for academic point of view. And when gamma rays or electron beam pass through food, there are collision between the ionizing radiation and food particle at atomic and molecular level, resulting in the production of ion pair and free radicals, and thus preservation takes place. As this is a type of sterilization in which no temperature is involved, so it is also referred to as cold sterilization. That is, food is free of microorganisms without high temperature. WHO and the International Atomic Energy Agency have recommended the radiation dose up to 1 rad. Rad is the unit of radiation. And in case of microorganism, the approximate sterilizing dose of bacterial endospore is 3 into 10 to the power 6 rad, while that for yeast and fungi is 5 into 10 to the power 4 rad. This is all about principle and method. 3 principles and 14 methods we have discussed. This is all for today. This is all about principles and methods of food preservation. Thank you.